I'm going to do the first 4 questions on this worksheet that has more practice with quadratic functions, because a lot of people are still struggling with the idea that the process can really be different depending on the form that the parabola comes to us in. And so it certainly is okay to always, sort of simplify the function until it looks in the normal ax squared plus bx plus c form. But for a lot of you, when you do that, you're messing some other things up and making it harder for yourself. So I just wanted to illustrate sort of 4 different things that can happen depending on the form of the quadratic. In each case, we're just trying to plot the significant points. So this will be the vertex and the intercepts primarily, and then all the rest of the questions we can answer from there. Okay, so for a function that's in this normal standard form, we certainly can get our y-intercept easily. That's just a matter of finding f of 0. So here f of 0 is negative 20, and we know that means that the point 0, negative 20 is on the graph. So that's my y-intercept. The vertex is also easy when it's in this form. The vertex x-coordinate, vertex x-coordinate is always minus b over 2a. Again, thinking of a equals 1, b equals negative 1, c equals negative 20. The a, b, and the c, that's the same as you would use for the quadratic formula. Anyway, so a is 1, b is negative 1, c is negative 20. Negative b over 2a then is negative 1 is 1 over 2 times 1, so 1/2. So therefore, the vertex of this thing has x-coordinate 1/2, and then y-coordinate is whatever you get by plugging 1/2 in for x. So we need to do a little side calculation over here, f of 1/2, and if you go through that, I already did it. It's negative 20.25, I think. Yeah, so negative 81/4 or negative 20.25, whichever. So that's the vertex. This parabola does open upward. Notice that the a term here is positive, and so that tells us that the parabola opens upward, which means that the vertex is a local minimum for this graph. Then the only other thing is the x-intercepts, which is the one part that actually has some algebra in it, because the x-intercept means that we have to solve the equation f of x equals 0, and so that means that x squared minus x minus 20 equals 0. When we're solving a quadratic equation, we should spend a minute thinking about if it factors easily, because that'll be easier in the long run if it does. And in this case, it does. Factors into x minus 5 times x plus 4. And so the only way x minus 5 times x plus 4 can be 0 is if x is 5 or x is negative 4, which means that my x-intercepts are the 2 points 5, 0 and negative 4, 0. So that's my basic inventory. I have my x-intercept, I have my vertex, and I have my y-intercept. And so from those 4 points, and my understanding about symmetry and so forth, I should be able to draw it. And I asked Google to do. In the second problem, I want to go through those same steps, but the one thing that this form is highlighting is the role of the vertex. So the vertex part of this, let me just start with the y-intercept, that's easier. The y-intercept, remember I have to calculate f of 0. That makes a little bit more arithmetic. I have a negative 1/2 times negative 2 squared, so that's negative 1/2 times 4 is negative 2 plus 8 is 6. So my y-intercept is at the point 0, 6. The vertex, I have to do no work whatsoever to get the vertex, because this is my vertex form. The x-coordinate of the vertex is whatever makes this part 0, so that's x equals 2. And then, of course, if you put 2 in for x, then since that part's 0, all you're left with is the 8. So this vertex form highlights the role of the vertex. So the x is whatever makes this part 0, and then the y is whatever that number is. So the vertex is easier to find that way. The x-intercept also is not hard to find, but again, there's no reason to ever have to change the form that the parabola is in. Working with it directly will always be less steps. So for the x-intercept, I have to solve the equation x minus 2 squared plus 8, so negative 1/2 x minus 2 squared plus 8 equals 0. And I can do that by multiplying out the left side and factoring, but I can also just separate it so that I have the perfect square on the left side. So I have negative 1/2 times x minus 2 squared equals negative 8. Multiply both sides by negative 2, and I have x minus 2 squared equals 16. And then I can take the plus or minus the square root of both sides. So x minus 2 is plus or minus 4. And so that allows me to get my two values of x, because if x minus 2 is negative 4, then that means that, that x is minus 2. And if x minus 2 is positive 4, then that means x is 6. So negative 2, 0, 6, 0 are going to be the x-intercepts. So I got my vertex, I've got my x-intercepts, and I've got my y-intercepts. But this kind of solution method for the quadratic is handy if the parabola comes to us in that vertex form, that form that highlights the vertex. In number 3, we can kind of just follow along. This is in our standard form, and so the y-intercept is 0, negative 5. I won't go through that again. Vertex, remember the x-coordinate is negative b over 2a, because it's written in that form, that ax squared plus bx plus c form. So minus b is 2 over 2a is 2. So the x-coordinate is 1. We just do this. So my vertex has x-coordinate 1, and then for the y-coordinate I've got to just plug 1 in for x into my function, and I think you get negative 6 when you do that. So I've got my y-intercept, I've got my vertex. The x-intercept, remember, comes from solving x squared minus 2x minus 5 equals 0. This is not already written in vertex form, so I could try factoring it, and if you try for a second to factor it, you'll find out that it doesn't factor. And so when we have something that doesn't factor, that's when we use the quadratic formula. So the x that makes this true, I'm just going to write it down here. The x that makes this true is minus b plus or minus the square root. B squared is 4 minus 4 times a times c, so that's 4 times 1 times negative 5, all over 2a, which is 2. So that's 2 plus or minus the square root of 24 over 2. So those are the x-coordinates of my my x-intercepts. This can be written in a slightly nicer form, because the square root of 24 is 2 times the square root of 6. And so you can see we have a 2 we can factor out of the top and cancel with the bottom, and that's how you'll get the answer that I have on the solutions. But we definitely have to have the quadratic formula there. Now when you're plotting points, just put those in your calculator. The square root of 6 is, I don't know, what is it, like 2.4, 2.5, somewhere in there. And so those are just numbers. They're not nice whole numbers, but they're just numbers. All right, last one, number 4. Let me just get rid of, box this off so I have some more room. And we're not worried about this one, so I'm just going to do that. Again, the y-intercept here I'm getting by just calculating f of 0. So in this case, f of 0 is negative 2 times negative 3 times 1, so that's positive 6. So therefore, 0, 6 is my y-intercept. In this case, I'm going to find the x-intercept first, because the x-intercept comes from solving the equation that we get by setting the function definition equal to 0. And since this is already factored, we can see that x equals 3 or x equals negative 1 are the two solutions, which means my x-intercepts are 3, 0, and negative 1, 0. So that's very easy to do when the graph is given to us when the function is given to us in this factored form. The reason I would do that first, again, I'll get rid of this. The reason I would do this first is because, remember, the vertex is halfway between. So if you're in a situation like this, where you know your x-intercepts first, and this will always be the case if your function is already factored, you will know what the x-intercepts are without having to do much work. And this is just because of the symmetry of the parabola. This doesn't happen for other curves, but the parabola is symmetric, and so the vertex, the x-coordinate of the vertex, is halfway between the x-coordinate of the x-intercepts. And so halfway between 3 and negative 1 I can find by just averaging them, add them together, and divide by 2. So therefore, the x-coordinate of the vertex is at 1, because that's halfway between 3 and negative 1. And I can always just add those two x's together and divide by 2 to get the average of those, and that's going to be my x-intercept, my x-coordinate of my vertex. So therefore, the vertex has x-coordinate 1, and then the y-coordinate is whatever you get when you plug in 1 for x, which I think in this case is 8. And so I get my vertex and x-intercepts and y-intercepts that way. But in that case, because the x-intercepts are so easy to find, and that you might as well find them first and then get the vertex from there. So that's it. I did include some graphs here. It drew this thing, and so you can see my x-intercepts are at negative 4, 0, 5, 0. My y-intercept is at 0, negative 20, and my vertex is down there. That's at about a half, negative 20.25. Couldn't get exactly on it with my coordinates, but so all of that is consistent. But those are my three significant points. The vertex and x-intercept or y-intercept are very close together there. All right. So in the second problem, again, use Google or some other package, but you can draw these things and circle your x-intercept, y-intercepts, and vertex, and just check it against the answers that you gave. All the other kinds of questions that are asked here about where is this graph increasing, where is it decreasing, what's the range, all that sort of stuff, really you can get from knowing these key points that you've graphed.